Everyone. So now we are going to discuss problem number B, find the array. This problem is from Educational Codeforces Round 100, rated for division 2. Time limit per test case is 2 seconds and memory limit is 256 megabytes. So let's read the problem statement. You are given an array of any elements in which every element is greater than or equal to 1 and less than or equal to 10 to the power 9. Let S be the sum of all elements of the array. Let's call an array B of n integers beautiful if every element of the array B is greater than or equal to 1 and less than or equal to 10 to the power 9. Also, for every pair of adjacent integers from array bi plus 1, either bi divides bi plus 1 or bi plus 1 divides bi or both, means in the array B, for every adjacent element, either one of the two elements should divide each other or both should divide each other. Also, the absolute difference of the elements at the same indices in array A and array B multiplied 2 times. When we take their sum, it should be less than or equal to the sum of all elements of the array A. So our task here is to find any beautiful array. It can be shown that at least one beautiful array always exists. Okay, so fine. So let's how should we? So this problem is means if you start thinking it mathematically, then it will mess up actually. So let's have something based on observation. Okay. So suppose this is the array A. We have elements from A 0 indices to n indices. Okay, actually. Let S be the elements of S be the sum of the elements of the array A. Okay, fine. Now SO be the sum of elements at odd indices. Okay, fine. Similarly, let S be the sum of elements at even indices. Here also we go. Now here we have some sort of mathematical equation. Okay. So we are clear that the sum of all the elements at odd position and sum of all elements at even position is equal to sum of all the elements. Fine. So here we can have that if sum of all the elements at odd position is greater than the sum of all elements at the even position, then from here we can say that 2 into the sum of all elements at the even position is always less than the sum of all the elements. Okay, fine. Similarly, by reversing the above statement, we get this, and if they both are equal, then we will clearly get this very equation. Okay, fine. Now we have to find array such that 2 into the sum of absolute difference of the elements at the same indices is less than or equal to S. Okay. Now let the array be of the form A1, A1, 1, A2, 1, A3. Means we replace all the elements at the odd indices by 1, or we replace all the elements at the even indices by 1. Okay, fine. So now hereby we can say by positioning one at even indices, at all even indices, or at all odd indices, that every adjacent elements means if ai and ai plus 1 are are adjacent elements, then either ai divides ai plus 1 or ai plus 1 divides ai. Fine. Now the sum of the absolute difference of a and b is either AC minus n by 2 or S0 minus n by 2. Okay, here because n by 2 we have written because we either replace all the elements by 1 at only half of the indices. We either only the odd indices or the only the even indices. So it's not AC minus n by 2 is not actually exact. Okay, it will depend whether an is odd or even, but uh, it can be said that means if it's even it will be accurate. Okay, so means it doesn't matter much, but it's not absolutely correct. So now from here we can get this. Thus we can prove that B is the required array for this. Okay, fine. So let's how will I put this down? Let's see that. So here we start with taking the number of test cases. Okay, we have t test case, and every test case we have two lines of inputs. The first line of input contain the number of elements in the array, and the second line contain all the elements. Okay, so we take three array of each of length n. Means it can be more memory efficient, but it's okay. I'm going by this. It makes it is easy to code. Okay, now we first take all the array elements, and now we will just copy it in A, B and C array. Okay, fine. Now what we will do that we will leave the C as the original array and make array A as this one and array B as this one. Means in array A what we do that we replace all the elements at the even indices by 1, and in array B we replace all the elements at odd indices by 1. Now we take two variables s1 and s2, both are initialized as 0. Now we'll take the sum of the absolute difference of the corresponding elements in the array A and C, which is the original array. C is the original array, we have not tampered with it. Similarly, we take a sum of difference of B array and C array s2. So if s1 is less than s2, then we will print out the array A, otherwise we will print out the array B. So it's finally a new line by our printing indel. So that's how we'll approach this problem. Thank you for your attention. If you enjoyed this video, please like, share, comment and subscribe my channel. If you have any doubts, please feel free to comment below. Thank you.